Alrighty, so this is the 2.4 learning target. This is the diagram about the different classifications of matter. This should be in your unit packet. So hopefully you can find it there and type in it. Okay, it's going to be pretty challenging because it's on Google Docs instead of paper. So just do your best. If it's not perfect, whatever. So matter. There's basically two overarching classifications of matter. Those that can be separated by physical means, so that means like actually separating them by physical means, and those that can only be separated by chemical means, so they're a little bit different. So these we can separate with physical means, these we cannot separate with physical means. The things that can be separated are mixtures. So if you have a mixture of something, you can separate the two things that are mixed in it, and then if you cannot separate it physically, these are called pure compounds. Or sorry, pure substances, not compounds. You'll figure out why in a second. Pure substances. Okay, great. Then, if we can separate them by chemical means, these are called compounds. And if we can't separate them by chemical means, these are called elements. So elements have their own box on a periodic table. So if I drew a particle diagram, they're all the same particle. See? They're all the same particle. For compounds, we have more than one particle. So there's a triangle touching a circle, but they're all identical. So I have a triangle bonded to a circle. That's my chemical. And then the chemical means is I could chemically separate the triangle and the circle. The mixtures, there's two types of mixtures. There's stuff with the same composition throughout and a different composition throughout. The prefix for same is homo, so these are called homogeneous. It's homogeneous, H-O-M-O-G-E-N-E-O-U-S. There's three vowels in a row there, so that's a little bit weird. And then different composition throughout, these are called heterogeneous. E-O-U-S. Different composition throughout. Particle diagrams of mixtures, you're going to have maybe some compounds with some elements, but they're not going to be bonded together. The particles, the groups of things, are not all bonded together. So there I'm just drawing some random stuff. And then these two particle diagrams are going to look the same. You can't tell if it's same or different composition throughout by the particle diagram. You would have to actually look at it. So same composition throughout, this would be like salt water. Because if you look at a glass of salt water, it all looks the same. Different composition throughout would be like a chocolate chip cookie. Because the composition is different. So if you're looking at the part that's just the chocolate chip, that's going to have the composition like chocolate. If you're looking at the part that's just the cookie material, that's going to have the composition like a cookie. So there's different compositions. Compounds. We have water, table salt, etc. So there's more than one chemical element there. And then for the elements, you just have one chemical element. Gold, hydrogen, etc. I think that's it for that slide. Let's continue. I don't know why it's not showing me this clear ink button on the smartboard, but it's not. Okay, great. So element are pure substances made of one kind of atom, represented by two-letter symbol. Example, oxygen, helium, calcium. So basically, if it has a box on the periodic table, it's an element. Compounds, two or more elements combined in a definite proportion. The definite proportion is the chemical formula. There's one, water, it's right there. Here's glucose. There's a ratio there, there's a chemical formula, the definite proportions. It has to have those numbers in order to be glucose. But they can't be separated by physical means. So I can't just pluck the carbon off the glucose molecule. I'd have to do some sort of chemical reaction in order to get those things to separate. Let me get rid of the ink here. Mixtures. Two or more substances physically combined. They do not combine in the same proportion each time. They have the same properties of the elements that make it up, and they can be separated by a physical process. So if we have salt water, its chemical formula would be NaCl and H2O. Notice there's the and symbol there. So these are not actually chemically bonded together. They're just mixed together. So we can separate these by physical means. The physical means would be to evaporate all the water, and then you'd be left with the salt residue in your evaporating dish afterwards. Okay, classification chart for mixtures. So the homogeneous mixtures, there's only one category, pretty much just solutions. Okay? For heterogeneous, there's two different ones, colloids and suspensions. These are all when you basically mix things with a liquid. So if it's homogeneous, it's what's called a solution. That's like salt water. Heterogeneous, there's a difference between colloids and suspensions. Basically, both of these are going to block light a little bit. Milk, you can't see through it all. That blocks the light. So that's going to be heterogeneous. If it's transparent, if you can perfectly see through it, it's a solution. Does not scatter light, it says down there. This scatters light. This scatters light. May scatter light, but not transparent. So both of these things, there's going to be something blocking the light. Basically, this goes from the smallest particle to the largest particle. So we have small, tiny particles. You can't tell the difference. This is like medium-ish particles. You can kind of tell that it blocks light. And then these are enormous particles. The difference between colloids and suspensions is suspensions will settle out over time. So if you mix up a bunch of sand and water and let it sit, eventually most of the sand is going to settle down to the bottom, and then you'll have the clear water layer with the sandy part at the bottom. Colloids don't do that. So this would be like milk. So if you leave milk in the fridge in a cup for a while, for a couple days, it's not going to settle out. It's going to be the same. There isn't like a shake well label on your milk. But there is a shake well label on your orange juice if it has pulp, because the orange juice is going to be a suspension and the milk is going to be a colloid. Colloids cannot be separated with filters. Suspensions can be separated with filters. So if you put milk through a filter, all of it's going to go through. If you put sandy water through a filter, the sand is going to get filtered out. Here's a picture of that. So here's a solution, colloid, suspension. You can see the particle size gets up. And the Tyndall effect down there, which you might not be able to see because of the lighting in here, basically if you put a laser pointer through it, in this first one you can't see the green light, but in this last one you can see the green light. So this first one would be a solution. The second one would be either a colloid or a suspension. To figure out if it's a colloid or a suspension, you would have to try to filter it. And if it filters out, it's a suspension. And if it does not filter out, it's a colloid. Examples of colloids from everyday life: foams, milk, fog or smoke, detergents, aerogel, blood, paints, or cosmetics. Paints kind of settle out, but it takes months, so, not really. Practice problems. So element and compound. Remember that for chemical formulas, you can't tell between the different types of mixtures, so we're not going to do that. Okay, this one we have two symbols, so that's a compound. Two symbols, compound, two symbols, compound. One symbol. I know that there's two letters here, but those two letters are one symbol, so that's an element. More than one symbol, compound, one symbol, element, one symbol, element. Now pay attention to this one and this one, because they're the same letters. They're both a C and an O. This one, the O is lowercase, so that means it's cobalt. This one, the O is uppercase, so that means it's carbon monoxide. So here's a silvery, shiny metal, and then here's a poisonous gas, all because one letter is uppercase. So make sure you're not making that mistake. This one's an element because there's only one symbol. I know there's a 2 there, but this is chlorine. This is chlorine gas. It's only chlorine gas. Even though it comes in a pair of 2, it's still just one element. 2 atoms, one element. And then this one's a compound because there's more than one symbol. Okay, basically said that. So which one represents a mixture here? So we need particles that are different, that are not bonded together. Here we have particles that are different, but they're bonded, so that's not a mixture. This would be a compound. Here, all the particles are the same, so that's an element. Here, all the particles are the same, so that's an element. This one, we have particles that are different and not touching, so that's a mixture. Can't tell if it's heterogeneous or homogeneous, though, from a particle diagram. Okay, mixture of one compound and one element. So this is an element, and that's an element. So these is a mixture of two different elements. Here's a mixture. This is a compound with the 4 circles there. That's an element. So this is a mixture between a compound and an element. So it's that one. This one, we have 2 different compounds. So this is one compound, the big thing in the middle, and then these are different compounds. And just because I've been doing chemistry for a while, I can tell that's water. Okay, number 1, which particle diagram represents a diatomic element? These are elements that come in pairs of 2. So that'd be this one. This is like our Cl2 that we did in the last slide. It's a diatomic element. This is a mixture of 2 diatomic elements. This one's just a compound. These particle diagrams are rather important. Here's the big one. So we have colloid, compound, element, solution, or suspension. Okay, great. So what do we have here? All these particles are the same. So this is our element. This one, all of these particles are the same, but they're made up of more than one type of circle. So this is our compound. And then we have mostly gray circles with some white circles. Here's mostly gray circles with a set of 3 whites, and then here's mostly gray circles with a set of 7 whites. So it looks like we have a small white particle, medium white particle, and large white particle. So I would say this is a solution just based on particle size. Here's our medium one, which is a colloid, and then our large one, which is a suspension. Woo! Great job, Mr. Rasmussen. And we're done. Great job, all of you.